Hello, and welcome to Most Significant Bit, a podcast that explores the connections between engineering, technology, humanities, and the arts. I'm Cai Parks, and today we are discussing how slime mold is used in research. In this episode, I will explain how Japan used slime mold alongside their rail system, what slime mold is, and other research being done with slime mold. In 2010, a slime mold called Physarum polycephalum shocked Japanese researchers. The railway system around Tokyo was designed and developed from years of research of the most efficient routes possible. A slime mold was placed in a petri dish with different sized oak flakes representing locations based on population density. Within about 24 hours, the slime mold formed itself into an almost exact copy of the Tokyo railway system. What took humans years of research and money took a single-celled organism less than a day to figure out. This is an excellent display of efficiency that nature develops over time. Now, what is this slime mold? Slime mold is a single-celled organism with many nuclei that is described as looking like a blob or a living web. To me, it looks like a symbiote from Venom. The slime spreads itself out to explore the world around it and mainly to find food. It moves through a pumping action that pulls and pushes the slime, and whenever food is detected, the pushes will be stronger in the direction of the food, meaning that more of the slime mold will be pushed towards the food. There have been many experiments of the slime mold solving mazes, and it has this maze solving ability because of the mucus-like residue that it leaves behind. If a route to food is blocked by a wall or other obstacles, it will leave mucus that marks it as a bad path so that it knows to avoid these paths in its future search. Then it continues to move in the other directions. These alien-like life forms can adapt in many ways, like growing new limbs to swim when they're in water, hibernating when they're frozen or dried out, and learning to survive things that it doesn't usually like. For example, they do not like salt. I think it kills them, or it's just not part of their diet, but they will learn to deal with it if their food is on the other side of a big pile of salt. Apparently, they also fuse with each other, and when they fuse, they pass knowledge between each other. So, if one slime mold had learned how to survive this salt exposure, then when they fuse, both of them, or I guess the one, will entirely be able to avoid salt. But how can humans benefit from this brainless but accidentally intelligent species? Well, we've been researching more and more ways that their efficiency can be used to aid in human problem solving. From finding the shortest, cheapest paths, resource allocation, and even computer network routing. Many experimental studies are testing how useful these slime molds can be, with pretty positive results so far. They can also show us how something without a brain can learn to deal with problems and anticipate periodic events and somehow store memory or quotation mark memory in its body and retain these memories even through dormant periods. Finally, there are some very experimental studies of slime mold in robotics and creating living machines or living sensors. Today, I discussed early slime mold studies that took place in Japan, what slime mold actually is, and how it's being used now. It seems like there's a lot to learn from slime mold, and I'm excited to see what knowledge can come from it in future research. Thank you for listening.